Imagine a universe governed by a grand, elegant cosmic ballet, where planets dutifully orbit their stars, following predictable paths born from the swirling dust of creation. We've come to understand this dance, to chart its rhythm, and to anticipate its choreography. Yet, sometimes, the universe reveals a rebellious streak, unveiling worlds that defy our expectations, celestial anomalies that challenge our very understanding of how planets are born and thrive. These are the lost worlds of the universe, planets that, by all conventional astronomical wisdom, shouldn't exist. They are rogue wanderers, cosmic jewels forged in unimaginable conditions, or inhabitants of systems so alien they warp our sense of cosmic order. Their existence whispers tales of unforeseen violence, miraculous resilience, and the sheer, boundless ingenuity of the cosmos itself. Join us now on a journey beyond the familiar, to explore these impossible realms, worlds that push the boundaries of what we thought possible, reminding us that the universe holds mysteries far stranger and more beautiful than we could ever conceive. Prepare to have your understanding of planetary existence expanded, as we delve into the secrets of these truly extraordinary cosmic outcasts. Our cosmic intuition tells us that a planet needs a star. A star's gravitational embrace provides warmth and light, anchoring its planetary brood in a celestial family. Yet, deep within the dark, expansive canvas of the cosmos, there exist countless rogue planets, worlds that drift through interstellar space, unburdened by a star's gravitational tether. These are true outcasts, celestial orphans on an endless, solitary voyage through the galactic night. How does a planet become a rogue? The most common theory suggests a violent cosmic eviction. During the chaotic early stages of a planetary system's formation, nascent gas giants can exert powerful gravitational forces, flinging smaller, less massive planets out of their orbits and into the cold, dark embrace of interstellar space. Imagine a celestial slingshot launching a world into an eternal exile. Stellar close encounters can also strip away planets, as a passing star's gravity wrenches a world from its home system. The sheer number of these interstellar wanderers is staggering. While difficult to detect, astronomers estimate that for every star in our galaxy, there could be hundreds, if not thousands, of rogue planets. If true, our Milky Way alone might harbor trillions of these solitary worlds, far outnumbering the planets bound to stars. They are essentially invisible, emitting no light of their own and reflecting none from a nearby star. Our primary methods for detecting them involve microlancing events, where a rogue planet passes in front of a more distant star, briefly magnifying its light due to the planet's gravitational field acting as a lens. Life on such a world would be profoundly alien to us. Without a sun, the surface temperature would plummet to near absolute zero, a chilling to 170 degrees Celsius for 150 degrees Fahrenheit, yet, the universe has a knack for surprise. Some theories propose that these rogues could sustain subsurface oceans of liquid water, kept warm by geothermal heat generated by the planet's radioactive core. If life could emerge in such an environment, it would be a testament to its extraordinary resilience, thriving in perpetual twilight, bathed only in the faint glow of distant nebulae and the internal warmth of its own molten heart. These sunless nomads challenge our very definition of a planet and expand our imagination of where life might conceivably exist. They are monuments to cosmic violence and silent survival, lost worlds charting lonely courses through the infinite, dark ocean of space. Planets are thought to form from the gentle accretion of dust and gas within a protoplanetary disk around a young star. It is a relatively calm, methodical process, resulting in the serene orbits we largely observe. However, some lost worlds bear the scars of a far more violent genesis, having survived cataclysms that should have utterly obliterated them. These are the unlikely survivors, worlds born from cosmic fire and chaos. Consider Chthonian planets. The term, derived from Greek mythology, refers to underworld deities, fitting for worlds that are the stripped-down, super-dense cores of former gas giants. Imagine a Jupiter-like planet orbiting perilously close to its star. The star's intense radiation and stellar winds can literally boil away the planet's vast gaseous envelope, leaving behind only a scorched, metallic or rocky core. These are planets that have been cooked and stripped bare, yet still persist, a testament to the sheer density and gravitational integrity of their remaining core. They shouldn't exist as mere planetary husks, yet they do, challenging our understanding of planetary evolution and stellar interaction. Then there are planets found in the most hostile environments imaginable, such as orbiting pulsars. Pulsars are rapidly rotating neutron stars, the ultra-dense remnants of massive stars that exploded as supernovae. They emit intense beams of radiation, periodically sweeping across space like cosmic lighthouses. The formation of planets around such an object seems impossible. A supernova explosion should incinerate any pre-existing planets. Yet, in the early 1990s, the first exoplanets ever discovered were found orbiting a pulsar called CCRB 1-5712. The most plausible theory for our standard model of planet formation, the core accretion model, explains how dust grains stick together, gradually forming pebbles, then planetesimals, and finally full-sized planets. This process typically occurs in a relatively flat, cool disk of gas and dust. However, some observed exoplanets possess characteristics that push the limits of this model, appearing as eccentrics that defy straightforward explanations for their existence. One of the most perplexing categories is hot Jupiters. These are gas giant planets, similar in mass to Jupiter, but orbiting incredibly close to their parent stars, often with orbital periods of just a few days. Our models suggest that gas giants should form much further out from their stars, where there is enough cold material like water ice to accumulate the necessary mass. The prevailing theory for hot Jupiters is planetary migration. These giants form far from their stars and then somehow migrate inwards, perhaps due to gravitational interactions with the protoplanetary disk or other planets. However, the exact mechanisms and the incredible efficiency required for such migrations remain a subject of intense research and debate. Their very existence, in such unexpected proximity to their stars, demands complex explanations beyond simple formation. Then there are planets found in environments previously thought impossible for any planetary formation, such as the dense, violent cores of globular clusters. These ancient, tightly packed spherical collections of hundreds of thousands to millions of stars are notorious for their frequent stellar encounters and high levels of radiation, which should disrupt protoplanetary disks and strip away nascent atmosphere. The journey through the lost worlds of the universe leaves us with a profound sense of awe and humility. From the solitary rogue planets adrift in the cosmic night to worlds performing intricate gravitational ballets around multiple suns. From survivors of stellar cataclysms to eccentrics defying formation models, each discovery expands our understanding of what a planet can be. These worlds, which by all initial accounts shouldn't exist, are not anomalies to be dismissed. Instead, they are invaluable teachers, pushing the boundaries of our knowledge and forcing us to reconsider the fundamental principles of astrophysics. They remind us that our theories are but approximations of a universe far richer, more dynamic, and more imaginative than we can possibly conceive. Each impossible world we uncover is a testament to the universe's boundless creativity, its capacity for surprise, and its disregard for our neat human categories. As we continue to gaze into the distant night, armed with ever more powerful telescopes and sophisticated detection methods, we are reminded that the cosmic canvas is infinitely vast and largely unexplored. The universe is not a static collection of objects following strict rules. It is a living, evolving entity, constantly experimenting, constantly creating, constantly defying our expectations. These lost worlds whisper a powerful truth. The universe is under no obligation to conform to our theories. And in that humbling realization lies the greatest wonder. It ignites our curiosity, fueling our relentless quest to explore, to discover, and to understand the astonishing diversity that lies beyond our own familiar skies. The story of these impossible planets is far from over. It is a continuous saga unfolding across the vastness of space and time, inviting us to listen, to learn, and to forever be amazed by the endless possibilities of the cosmos.